Wenn jetzt die
If the
Funktion nicht
function doesn't work now, I usually only notice it years later during integration and testing processes. This means we actually see a lot of twin error, because then the testers have to start searching, who is responsible for this now?
What?
Es steht
It's mentioned in every current report that competitiveness in Germany has come under considerable pressure, and this is mainly because we need to take a closer look at how engineering actually works. So, how do we develop products, complex products, that are not becoming easier to develop, but rather more difficult? Do we have the right methods, the right tools for this? This is really a matter close to my heart, and I am happy today to discuss the topic with one of the most promising startups in this area, Spread AI. Today, I have the founder and managing director, Philip Knoll, here. The little story that connects us is that he was actually once one of my students, and indeed learned a lot about engineering here in Paderborn in the first step, and has now, I believe, made a very exciting company out of it. And today, we want to look into the discussion. Welcome, Philip. Thank you. Hello. Nice to have you back here in Paderborn. We've actually known each other for quite some time, as I already mentioned, through your studies. I did have to think a bit. There were probably about 200 more theses in between. But you did a thesis here about 10 years ago, and as I noticed, I also tested you orally in lectures in the field of systems engineering, with very good success. Yes, even back then. So the talent for the topic of engineering and recognizing its importance, you've always had that. Then, I believe, you took a side trip to Mercedes, and then theory met practice, Philip. Yes, exactly. So, very nice to be here again. A lot has changed. And yes, the matter close to my heart is, of course, similar for me, I think, as it is for you. You inspired me there about 10 years ago. I then went into the industry, so positions, Mercedes, Porsche. Also worked in the consulting area at Porsche, and of course was able to gain a lot of insight into the respective companies. And yes, a bit like the point, what I actually understood, or the mindset I got from here versus how it really is in reality. Handled differs a bit. And, well, that's why the point was, we see on the horizon that the products will significantly change, hashtags, software-defined products. And yes, eventually all the problems could be traced back to one issue, really the engineering information. And that's when my co-founder and I said, it can't stay this way. We have to change it, and we'll change it from the outside. And essentially, we founded Spread. Yes, so that's the founder's story. Yeah, super cool. I find it really exciting because at first glance, most startups focus on other areas, even when it's about AI and such. But you have been focusing on this engineering topic for years now, and everything is in focus, and the challenges are clear. So for many, it is not clear, even when I speak with many politicians. They do not know under what pressure engineering actually is here in Germany. And if we do not strengthen engineering in Germany and bring it to the state of the art so we can develop this system, then we will probably no longer produce them and will likely disappear as an innovation location, or at least lose the top position that we still have. But we will certainly lose it, and we certainly need to do everything we can to defend. And of course, that includes innovative solutions, and you offer something there. What exactly does Sprada do? Where do you focus on saying that's the core of your spin-off? To really bring engineering up to speed. So we say, just as you say, in Germany, we actually do not have a skill problem with the engineers. We actually have a problem that, due to software-defined products, or more digital functionality in these products, the networking and complexity in these products or systems becomes significantly greater. And it is an issue of efficiency and transparency in the first step, so that Engineer 1 from Department 1 does not know what Engineer 2 has really specified and developed, even though later both components from these engineers have a lot to do with each other in the product. And this transparency must be established. And that is why we said the greatest efficiency losses today are actually with our customers or in the industry. Our customers are all companies developing complex systems such as vehicles, defense systems, aerospace, or agriculture. That's where we are involved. And we said we need to take the product information, really the outcome that results from various development processes over several years, abstract it. So now let's say really connect the V model and bring it to one language to identify these dependencies in the first step, and then with all possible players in development, but also later in production, after sales, or aftermarket, this information on how this product really works. Share, yes, spread. That's why the name, translating and spreading development or product data into understandable information. That's essentially what the original idea was, and that's exactly what we do. Yes, as you just said, for a few years now, over 5 years, with 130 employees. We chose Berlin as our location, so that's where our headquarters is. And, yes. That is actually the point of what we do. Software platform that encompasses product knowledge in all sorts of areas. Absolutely. Product intelligence or engineered intelligence. Yes, absolutely. So if you hear that now, I hear myself a little bit in my lecture, because these are exactly the topics: creating transparency, the communication between the various involved stakeholders. So we're actually dealing with the basics of systems engineering. One naturally wonders why. Only you listened, and perhaps the companies did not. But it is, of course, super exciting because I see it myself. It does need technical solutions at the end of the day, to implement that as well. And I think an accelerator is certainly the topic of AI in this whole context because it simply enables things. It even says it here as well. I have been running around for 15 years saying we need to train people in systems engineering. For 5 years, I really have to run around. We need AI-supported systems so that they can create these solutions and this transparency more effortlessly. No one is against transparency, just against additional effort, because people already have to do an insane amount. It's not like we're worse off. As you say, always insanely great engineering education, insanely great engineers. But he might be missing a tool or two at that point to better manage the complexity that exists. Without question. Exactly, that's what we think too. We sometimes really say craftsmen without hammers, at least for the challenge that exists today. South. We all see the principles in our lives now. How often we are on our phones, how much data we actually generate and exchange with each other. And it can't be that. To develop such similar products, we are still working with tooling and partly using methods from 20 years ago. And we just have to understand that data is key. And we particularly distinguish between structured and unstructured data. Both are abundant in the development process, and both have very, very important components. In the first step, we always took the structured information because we said it is really foundational AI research. So much on the move when it comes to image recognition, or now, as we see, the large language models. And it is so cost intensive that we do not really engage in fundamental research on our own at Spread, but we said we start in the first step with the structured information because they are super important, because exclusively with them, yes, with the information from the unstructured data, like requirement specifications and so on, you still don't know how the product works. That's why, right now, it's coming together very intensively, and we also see huge potential there. We also see that with the first customers. It works very well, bringing structured and unstructured information together. What do you see as the added values for the customers now? So, creating transparency, and then right away, what would you say, where you really say, that can eventually be quantified. I wouldn't say specific numbers of how much customers have saved, but based on the feeling, where would you already say it can really be quantified, making the benefit quantifiable, the whole thing? Yes, well, where we are. Sure, we have use cases mostly in the development area, also in production, where it's about errors and corrective actions, especially flashing of new functions. So a very strong auto case, actually, just like in after sales. I drive into the workshop. have a light flashing somewhere, and our technology is then used to narrow down what can really be the causes and what the workshop might need to replace or reflash. But in engineering, it's actually a bit more exciting. Of course, cases in engineering are often somewhat more complex. But you have to understand the scale of what is happening in companies today. There are studies that say, in effect, 50 to 70% of engineers' working time is wasted searching for information. Yes. And when you consider the R&D expenses of the industry, they are just very, very large amounts. And it leads to a very good case development project, meaning I'm launching a new model series somewhere. This is initially industry independent, partially. But then it's about developing something, and of course, I need to know if it works together. Now, for example, a functionality like a head-up display. The head-up display is ultimately supposed to show a navigation map or the speed. This means it requires data from 7 or 8 other control units, or from very, very many signals, because there are also players who have significantly fewer control units. And that is not transparent. So no function manager currently knows, not transparently, okay, what do I actually need for that? If the function does not work, then I usually only notice it years later in the integration and testing processes. This means we actually see a lot of trial and error, because then the testers start and have to search. Who is responsible for this now? Yes, which engineers do I need to ask to fix this error? That means where we actually go, and we are naturally very strongly value-based, because our customers simply, when they use our technology and obtain software, there needs to be a business case behind it. And we just say speed, with consistent quality, so really development speed of entire vehicles or complete products and their functionalities. It's a huge topic, and with consistent quality, which should never be forgotten. Because I can, of course, also become significantly faster with quality. This is essential. We significantly contribute to that. And cost savings. In error management, actually everywhere in the entire value chain. No, well, now I have been teaching this for several years already, for decades actually. And that is actually the classic case that can only be explained in a very abstract way to the students at the beginning. They mostly don't believe it. They say, what you're telling us can't be true. You always talk about the V, about the development, and say, the V is arranged in such a way, it has a purpose and reason why it's a V. Because on the left, specification and development happen, and then testing on the right branch. And you test in the right branch against the left branch, hence this V. And it is already in many places, just as you say, which many then always deny, that in the right branch one simply tests the system as healthy in general. What simply wasn't transparent at the beginning, where the interfaces weren't clearly defined, where sometimes on the right side you don't even know exactly what you need to test. That's why you test too much or too extensively, and to do the specific, that is. It's clear you save time and then you save money because eventually you save a lot of iterations. And the big vision, which I believe is certainly worth the effort, especially for the author here, is to eventually move towards virtual homologation. For that, I really need to know what I'm testing, how I'm testing, to truly get a vehicle approval for, in this very abstract ideal case, a lot fewer kilometers had to be driven on the test track, actually achieving it on the first try, like in aerospace. Because there you only have one attempt when landing somewhere in space or on the moon or wherever, actually getting it first time right somehow, and achieving it faster and more cost effectively. And that's of course a super cool solution you're doing. Maybe a bit technical, without going too much into details. What is the technological core? AI is quite a lot. But is it a kind of knowledge graph that you build about the constructs and then create this transparency through it? I don't want any secrets, but what can you tell us? Yes. Well, basically, when we talk about our technology, we first talk about 3 layers. One is because we do not proceed by saying, dear customers, you now have to replace your entire IT infrastructure, because that's simply not work. Most of the time, it doesn't work. And that's why we say there are 3 layers in our technology, because we often overlay existing systems. Our customers define the items on the left side. V, in many different systems and really test them in a try and error manner on the right side. And this applies to the entire industry. We overlay them, and that is why the first layer is rapid ingestion, where we receive information. And that we can connect and really receive live data from existing systems about the products. The second layer, that is exactly what you say, knowledge graph. Yes. In the end, we call it product twin, but the technology behind it is exactly a graph. Yes, knowledge graph, which is technically a bit complex. There still is. Because we, of course, yes, have been focusing very intensively on API first for several years now, and naturally every field that ends up somewhere in our system. So every node, every relation should be available as an API. Yes. So there in the middle, that's actually, yes, that's already the core of our solution, knowledge graph, which truly represents how a function is realized or what requirements. So if we stay in the V model, the side, to truly trace the requirements, and ultimately then continually match with live information from the right side. And this happens data technologically, primarily in the knowledge graph. Above that is what we call the action cloud. It's really about realizing use cases as quickly as possible. What we have learned in recent years is that our customers, we have very large customers. The first customer at Mercedes-Benz was the first customer over 5 years ago. And our customers naturally also have quite strong opinions, even when it comes to their engineering. This means the solution, so how the engineering must work exactly, and then also how a technology ultimately looks. This means we always had to ensure that our solutions are flexible, yes, adaptable, and can also change based on different processes. And that's why we ultimately had to build a platform that has exactly such layers. And each element, you could call it a microservice. We ultimately call it, yes, reusable product components. That's how it's essentially structured. So that I can provide as many use cases as possible across different industries as quickly as possible. So ingestion, product twin, action cloud, and ultimately a point that you have been pushing a lot recently is of course the whole topic of LLMs and agents, etc. We have also integrated agents, which is why we call it agentic engineering intelligence. On one hand, really in the connectors, because connectors change. Yes, of course, flexibility is needed. Ideally, it runs automatically and not that someone has to do it manually. There we have integrated agents to receive information even further and faster, as well as to receive text. And at the top level, in interaction with the end users, so that the end users can ask questions much more freely, and they receive information from both structured and unstructured sources immediately and flexibly. A very large construct, but the problem is quite large and complex. Yes, of course. But you're also approaching it cleverly by saying that you don't have to tackle the entire IT itself in the sense of we have to replace it first. Because for car manufacturers, that's the years until the decades-long projects when they exchange their IT systems, and behind it lies a strategy process where at the end of the day, a strategic decision is not always made, but one, let's say, there are many factors involved, like this IT development plan. That's why it's clever to just connect and say, I don't really care which systems. And I think you said that so casually now, but of course I can't get that from decades of painful experience and understanding. I don't think there's any area in the company, the kind that is so attached to its processes and its tools at every level from top to bottom, like the engineers in development. First of all, a very change-resistant area. It must be said that anyone who has experience there, that's just how it is, and it is justified, right? People simply have tools they use and develop with, and they don't want to just replace them. And it was also the case that people used to, me too, maybe also during your studies, but definitely me. We really had to learn entire systems for a whole semester just to develop with them. We never really got to learn about development. I always said during my studies, we first had to learn CAD systems, simulation systems, and whether we developed or designed something was practically always just a demo because the systems were very complex. And I also believe, and I see it right now, that the agent based systems are simply the solution to reduce the complexity of the systems so that people can focus on the actual task, namely developing and creative work. And your solutions contribute completely to this by 100%. And that is a very important point. Yes, I see it exactly the same way, because the products today could be better if people had the time to really think about it. That means they are, I believe, also the attachment to systems, in our view, is decreasing because society is simply much more digital, meaning a lot more with cell phones, etc. When you show people that there is information important to them, previously only conveyable through weekly emails to a distribution list of 60 or 70 people, um, then many of our users, of course, realize, okay, this is something I didn't know before. And because of that, they also like to come to the point where they, yes, become more open to new solutions. But we also say if there is no value and no added benefit for our customers, and thus also for users, who are often, of course, the engineers, then we also do not have a right to exist there. So, of course, forcing something just because we would like to sell it. We do not proceed that way because we do not believe in a sustainable solution. Absolutely, I completely agree with you. A very important point that I hear repeatedly, and over the past few years I've endured a lot in many discussions. Do we even need the engineers at all? No, it's all software, and we need. I am also a professor in computer science, that's why I am familiar with all the disciplines quite well, and I am, I believe. This is also our Institute's approach, very open to disciplines, because I believe we need them all. And I think it will especially not work without engineers in the future. That is practically impossible, especially for the economic topics, the industries we actually represent in Germany. That's a position of strength, because many other countries cannot do that as well. I'll say, the German engineer still has a reputation, and that is important, and that's why it's also important that we empower them. Recently, most people with me know this because I've already recommended it to some. I also listened to an interesting podcast from the USA by a 16Z. A 16Z. So, Anderson Horowitz. They are really like the big cats probably in Silicon Valley here, who actually come from the software corner, venture capitalists, who have in these software systems, and has a partner who was asked, what are actually the talents of the future that we need? And she said, so in the coming years in the United States, this is all related to the USA. We need to shift away from we only train people in software and need to train people again in the traditional engineering training because otherwise we will not solve all these problems we face because they are not purely software problems, but we need this full stack engineering. And I believe that is actually where we are heading. What we are also seeing, what makes up this systems engineering, that is software. The sophisticated vehicle is just not only software, but software is just added on top of that, making the subject complex. But you need the other subjects too. And I think it is very, very important to understand that we are currently at the renaissance of engineering. We actually need much, much more of it because we can't solve all these issues without engineers to do this, this, this. In my view, this is very contrary to the situation in universities, where we currently cannot attract many young people to pursue this education, but rather to become pure computer scientists or focus solely on software or entirely different subjects. Man, you can do so many great things with that. I don't know how you see it, but my argument is always for having great careers, like the one you have now, to develop something like that. It's also because you are an engineer. That's right. Um, so, in my opinion, we have a problem which, across several disciplines, uh, because in the end, what happens in these complex products and everything that actually constitutes Germany in the industry is, besides the process industry, complex industrial goods that we were able to develop very, very well. And then, of course, we're able to export everywhere because the products were simply better than the rest. And such products always have a software component. The software component is increasing significantly a mechanical component and an electronic one. Electricity, electronics share. That's why you are also design engineers. By the way, how many counters are here? And today it is such that perhaps the students are leaning more towards the digital side because they are naturally confronted with many things in the B2C with digital matters. Um, but I see it as very important also in electronics. And then, really, where it moves is usually the mechanics. This interdisciplinary knowledge is essential, was essential for my way of thinking in recent years. That we did not focus exclusively on one topic, because I believe there aren't the biggest levers there. So now in a corporate area, body development, something like that, you won't get 50 or 60% just by being better in this area. You gain the 50 or 60% search time. They always occur exactly when domain boundaries are crossed, meaning if you are only in software, then you don't have the advantage of knowing that somehow the data processed in the software must also come from somewhere and be distributed to some actuators via some signals and some lines. That must be considered, or at least in our business. That's why I find this reputation. Yes, well, of course, I studied industrial engineering. Money is unfortunately always important. But labeling the reputation of a mechanical engineer as a sheet metal bender, I think is not appropriate and not up to date. Therefore, I can recommend taking up such topics. Yes. It has a lot of these interdisciplinary topics with you, too. In the field, and also here in this institute, 10 and more years ago, I got to know. Therefore, I can't quite understand that the numbers have really gone down so much compared to 10 years ago. Back then, the numbers were still better. So I would really recommend, if I were to study again today, to do something similarly interdisciplinary, but of course also for the universities. Um, Not to close oneself off just because it's now called mechanical engineering, and we have had machine elements 2 and 3 in it for a long time. Whether one really still needs the last mechanical details in such depth, that must, of course, be questioned. Absolutely. No, there I am also a big supporter. We, of course, must ensure that the engineering sciences must keep up with the times. But it's just as you say, the image of a mechanical engineering student isn't that he's standing in front of the machine in a blue coat and covered in oil, you know. Maybe you do that once during an internship operating a machine. It doesn't hurt. But it's just, we're simply going in this direction, full stack development, and many of our engineers are also, right, really intense AI users, those who really manage to implement it properly. And I think it's just exciting to be enthusiastic about technology because you can solve an incredible amount with it. And incredibly, you know, you can create a business, but you can also truly address societal problems, as they all have a technical basis, somewhere in their origin, and certainly in their solution. What is maybe, in conclusion, what are your plans as Spread AI? What are the next big steps you're aiming for? How far can you see? What's on the agenda? Yes, so we are already trying in our vision roadmap to change engineering. A similar slogan has been used in Engineering the Future. We have it too, of course. Similar. And what we see in the short term, so the next 1 or 2 years, is really a move, just like you say, agents, to bring that together well and thus to be active in further industries. Our footprint naturally comes historically very strongly from the automotive sector. It's currently moving more and more in the defense aerospace area, as well as agriculture. But also, we see that in mechanical engineering, some things are changing. There, we ultimately want to enter, as well as internationally. We want to further bring our technologies into the market. We have international customers, but not so many, so a very strong footprint also in Germany or in Europe. We'll do that. And then the technological aspect, yes, full throttle, AI, in connection with the structured information under the knowledge graph. A lot will come. I do not want to talk too much about the distant future, but we do believe that complex products like vehicles and so on can definitely be developed in 1/10 of the time, and we're working on that, just like at half the cost. And that is ultimately, those are our goals. So that is like our North Star, yes, 10% of the time with better quality. That's what we're pushing for. And, well, we'll see. We also don't know exactly what's going on in the technology market. We always have to react very quickly when something changes so that we don't end up becoming the old ones and the main players somewhere. Yes, super. Exciting topic, exciting field, an incredibly cool success story so far. But I believe you are probably only at the beginning of your success, and I truly wish you all the best for that. And of course, for the coming years. Good luck. We'll stay in touch anyway, and maybe look at one thing or another. A bit missionary for the topic, but of course we also ultimately want to continue engineering successfully in Germany, because I believe that is the foundation of our success in the country, and I think we want it that way so that future generations can also benefit from the prosperity here. Therefore, it's just incredibly important, and I wish you all the best. Many thanks. Thank you. Yes, that was today's episode with Spread AI. I hope you had fun and gained insights. I found it really great because I could see what former students can actually achieve, and that they listen more closely in lectures than a professor might sometimes think. And I am already looking forward to the next episode. See you then.
Ciao.
Let Spread handle all product complexity for you so you can unleash the full innovation power of your engineering craft. Engineer the products of tomorrow with Agentic Engineering Intelligence by Spread.